What is up? How's this awesome Saturday evening treating you? हम लोग शुरू कर रहे हैं. Why are we starting today? Oh yeah. Haloalkanes के बारे में we're going to look at preparation. हम already कर चुके हैं. तैयारी कैसे करते हैं haloalkanes की, haloarenes की different तरीके से. काफी name reaction देखे थे. Woods reaction, Sandmeyer, this, that बहुत देखे थे, right? Now we are going to figure out SN1, SN2 reaction क्या होता है? SN1, SN2. देखते हैं उनमें से एक आज करेंगे एंड आई विल टेल यू व्हाट इज द डील बिहाइंड दिस SN12 मतलब क्या होता है. ऑलराइट, दैट इज द मेन फोकस, बट बिफोर दैट वी गॉट सम अदर स्मॉल थिंग्स टू iron out. Physical properties, boiling point, melting point, etc., etc. That is the focus of this session. How you doing? Yeah, let's get started right away. So, as always, I'm going to just quickly open up the NCERT. Well, already khula hua hai. NCERT. Here you go. Yeah, we're going to look at what we're going to do from the NCERT. Hey, Mike, how you doing? Take a second. Oops. The usual. Not this, that. All right. Okay, let's make it slightly larger. Okay. So, you remember the last session I spoke about all of this? मैंने कुछ ऐसे सवाल भी कराए थे आप लोग के लिए where we were supposed to figure out mono-halo products and all of that, keeping in mind stereoisomerism, etc. So, yeah, similar question there over here. We're going to do all of this. Physical properties सारी करेंगे. Yeah. These graphs will explain as to what is happening here. Why the logic is very straightforward. ये बहुत complicated नहीं है. और इस पे अगर सवाल आएगा तो that's a lucky thing to do. Solubility, reactions. We'll start off with nucleophilic substitution reaction. अब ये बड़े-बड़े शब्द लग रहे हैं, but it's really not a big deal. Nucleophilic मतलब something that likes nucleus. मतलब it must be a negative charge, right? A negative charge species, or is it negative charge, or it could also be electron rich. So we're going to focus on this idea. Electron rich species जो reaction करेगी substitution मतलब कि हैलोजन को निकाल के उसकी प्लेस ले लेगी. सब्स्टिट्यूशन है ना, नॉट एडिशन, सब्स्टिट्यूशन. एडिशन रिएक्शन भी है, वो हम लोग बाद में देखेंगे. ठीक है, ऑलराइट. देयर इज आल्सो समथिंग कॉल्ड द एलिमिनेशन रिएक्शन व्हिच वी विल सी नेक्स्ट टाइम. या, एंड सम इंटरेस्टिंग थिंग्स. यहाँ पे कुछ स्टीरियोकेमिस्ट्री की बात भी हो रही है, कॉन्फिगरेशन, कायरलिटी, एटसेट्रा. ऑल दैट इफ यू वांट, गो टू माय बेंटो लिंक, डू स्टीरियोआइसोमर. मैंने डिटेल में किया है ऑलरेडी लास्ट ईयर, यू कैन चेक दैट आउट. सो फॉर टुडे वी आर गोना फोकस ऑन फिजिकल प्रॉपर्टीज एज वेल एज SN2 reactions. Check out the name, it says SN2 and not SN1. I'll tell you what's the deal behind it. Yeah, that's the goal of aaj ka session. Yeah, that's what we're going to do today. All right, let's get started. Here's a quick question. जो AIPMT 1992 में आया था, इनमें से कौन सी चीज सबसे जल्दी रिएक्ट करती है HBr के साथ? HBr के साथ जल्दी, फास्टेस्ट. इंटरेस्टिंग, राइट? इन अ लॉट ऑफ आवर डिस्कशंस हम लोगों ने टाइम की बात नहीं की है. वी कीप सेइंग कि एनर्जी जो है सबसे स्टेबल कौन सा होता है. Here we talk about fastest. Okay, that's interesting. Okay, so there is an idea of relative rate of reactions. We'll kind of look at it. Broad ideas हम लोग उसको देखेंगे. But what's the deal behind this? How do I figure out सबसे जल्दी किस चीज से रिएक्ट होता है? Okay, well, okay, can I draw these structures? Maybe that will help, right? 2-methyl propanol. If I draw the base thing, I've got prop मतलब 3, prop मतलब 3, prop. Okay, so all of these is propanol, 1-ol यहाँ पे आ जाएगा, 2-ol इधर आ जाएगा, 2-methyl मतलब यहां आ जाएगा, 2-methyl यहां पे आ जाएगा. So looking at this is a tertiary carbon, right? So मेरे हिसाब से this should be the fastest reaction, right? This is primary with a isopropyl group attached to it. This is secondary and this is primary again. So out of all of these, मेरे हिसाब से it should be this one that reacts the fastest. A quick recap of what we did in the last session. उसी चीज को हम लोग यूज यहाँ पे कर रहे हैं. ठीक है, प्लीज रिवाइज दैट अगर वो आपने नहीं देखा है तो. दिस इज इंपॉर्टेंट. ऑलराइट, दिस आई फील इज व्हाट शुड हैपन राइट ओवर हियर इन दिस पर्टिकुलर क्वेश्चन. फिर से मैं इसको यहाँ पे ड्रॉ कर रहा हूँ एंड या इट्स स्ट्रेट फॉरवर्ड कि इसका आंसर होना चाहिए B, which is this. Another quick question. What is the total number of possible monochloro derivatives of 2,2,3,3 tetramethyl butane? अब ये क्या बोला है, थोड़ा ज्यादा हो गया क्या? 2,2,3,3 tetramethyl butane. अच्छा, what do you think? मोनोक्लोरो डेरिवेटिव कितने हो सकते हैं? दाल में कुछ खा लिया. I feel this is weird. Okay, let's draw the base, right? 1, 2, 3 and 4. ठीक है, all right. I'm not gonna put the numbers over here because they're gonna crowd things up. So butane है, okay, that's the root. Then there is 2, 2, मतलब okay, दो यहाँ पे हो गए और फिर 3, 3. Interesting. Okay, so let's draw one more here and then another here. So that is a lot of methyl substituents and look, this looks like a symmetrical compound. मतलब कि essentially I am connecting two tertiary methyl groups. Doesn't it look like that? This is one tertiary methyl group. This is another tertiary methyl group, right? दोनों को हम लोग जो है tertiary butyl. What am I saying? So tertiary butyl methyl. Tertiary butyl times 2. Pretty much यही तो है, right? That's what it looks to me like, right? What do you think? आपको क्या लगता है? Okay. Yeah, so that means it has 8 carbon atoms. Sure, it does. You got 4 base ones, then 5, 6, 7, 8. 8 hai. Okay. Why am I doing all of this? Why am I counting? Because see, it doesn't matter where I put chlorine. It's going to be the same compound. Whether I put chlorine over here, or let me put it, make it a different color. Yeah. Maybe or kaun sa color use kare? Let's use a darker green. Right? अरे हरा use नहीं होगा क्या? Okay, one minute. Some buggy. Okay, dark blue here. Or if I put it over there, or if I put it over here, it's the same compound. Which is very interesting. So if you go from the naming point of view, all of these are same, right? ये सारे equivalent है. Write that here. They are all equivalent. So इसका answer very interestingly is going to be one, just one compound. Hi Pooja, how you doing? So whatever you do here, you're going to get just one compound. The main thing, as always, is to draw this structure. And you will see NCERT में काफी जगह आपको स्ट्रक्चर दे के बोलते हैं करना. स्ट्रक्चर देने के बाद करना तो आसान है, बट अगर नाम दे दिया, so you are then tested on nomenclature and you also have to figure this out. So this is why this question is pretty interesting. Anyway, इसका आंसर होगा मेरे हिसाब से 1, right? Labek, Mehak and Pooja, do you understand? All right, great. Awesome. Simple one right here. Okay, let's start talking about physical properties. I like doing a couple of questions at starting just to fire everybody up, and then we get into actual things. Okay, so there are multiple properties to look at, yeah, and all of these are going to be logical. First one is a little, I mean, जो है वो है. Rest of these you can figure out with some sort of logic or the other. ठीक है. Color and odor. Well, that's interesting. Well, they're just usually colorless. Okay, if you're asked this at all. These develop some color when exposed to light, mainly because, well, yeah, you learned about the whole color thing maybe in the lab manual. Check out the lab manual and also coordination compounds as to why color gets developed, etc., etc. They have a sweet, weird smell to it, but yeah, they're colorless. Yeah, they have a sweet smell. This is small thing. Let's get over with this. Boiling point. This one's interesting. This one's very interesting. There are many factors that affect the boiling point of this. Okay, the simplest ones is polarity. You remember that there is a difference in polarity between carbon and X, clearly, right? This takes a slightly more positive, hence delta positive, and the X takes a slightly more negative, which means the pair of electrons are towards the halogen. That's fine, right? That's not rocket science. Yeah? Okay, great. So अगर polarity ज़्यादा हुई, तब boiling point ज़्यादा होगा, और अगर polarity कम हुई, तो boiling point कम होगा. That's what I think. What do you think? That's my, broad stance. Branching of parent chain, we'll talk about this. What is branching? Well, again, you studied this from GOC and hydrocarbons and all of that. Branching matlab वही है कि propyl, isopropyl. That's branch, right? Okay, we'll look at both of these. Let's explore polarity in a little bit detail. Okay, so as expected, and remember this, देखो, polarity of CX bond, polarity has to do with two things. Yeah? Dipole moment has to do with distance times electronegativity. It's a product of both of these things. Hence, this is why, and I've given you this exception in periodic table. If you've been studying periodic table with me as well, the polarity इसकी ज़्यादा होगी. And we just did it last session also, in fact, that the polarity of the CCl bond is going to be more than the CF bond. Hence, the boiling point also is going to follow this same order, yeah, as polarity itself. ठीक है? Cool? Are we good on that? Yeah. Hi Vajid. Hi Disha. How are you doing? All right, blood. Thank you. Let's keep going. And give me any inputs if there's something you don't follow. Just let me know in the chat. Otherwise, I'm going to just continue. All right. Great. Cool. What's the next idea? Now, the second part of this makes things a little bit interesting. Okay. You would expect that this factor alone decides the boiling point, and hence इसका जो है boiling point सबसे ज़्यादा होगा. But that may not always be the case. Although polarity इसकी सबसे ज़्यादा है, there is another factor at play. Van der Waals forces. Do you remember what Van der Waals forces are from chemical bonding? Coincidentally, I am doing bonding on the 11th standard students, right? With the 11th standard students right now, you can check that out. But Van der Waals forces, अगर कोई बड़ी चीज है, okay, if there's some big substance, like say iodine, like it's pretty big, bromine smaller, chlorine smaller, fluorine is really tiny. उसमें Van der Waals forces ज़्यादा possible है simply because it's large. Revise the theory about Van der Waals forces to try and recall why this is so. Because of both of these factors, this is a dominating factor. ये चीज, ठीक है? इसीलिए बॉइलिंग पॉइंट का ऑर्डर एक्चुअली ये होता है, ओके, एंड नॉट व्हाट वी सॉ ओवर हियर. सो श्योर पोलैरिटी इसकी ज्यादा है, मतलब दिस बॉन्ड इज प्रॉब्ली हार्डर टू ब्रेक इफ यू टेक द एनर्जी पॉइंट ऑफ व्यू, बट हम लोग अभी सिर्फ एक पॉइंट की बात करें, टॉक अबाउट बॉइलिंग पॉइंट. बॉइलिंग पॉइंट ऑर्डर इज दिस इटसेल्फ, ऑलराइट. आई नो मैंने शुरुआत में बोला था कि दिस इज गोइंग टू बी द बॉइलिंग पॉइंट, बट इट्स नॉट, राइट. दैट वाज द ऑर्डर ऑफ पोलैरिटी. दिस is the order of boiling points because of van der Waals forces. It's pretty interesting. So you can look at a couple of graphs. It's there in NCERT. That's why we're quickly doing it. If you increase the length of the chain, which means again, what is happening here? Mass is, higher, right? अगर mass ज़्यादा है तो boiling point ज़्यादा है. That's all that's happening over here. So length of chain increases, boiling point also increases. This is in Kelvin, which means this is around room temperature. See, 200, this is around 250, maybe around 260 or so. You can check the NCERT, okay? We'll do that. We'll look at that as well. So as the mass increases, boiling point increases. And boiling point, मतलब कि it's mostly a liquid at room temperature. That's what all of these say, right? That's what this means. But if a boiling point is around room temperature थोड़ा ज़्यादा, मतलब ये सब liquid या फिर gas हो सकते हैं. All right. If you compare, now we're fixing the length of the charge. Length of the carbon change. Carbon length fixed. इस case में, as expected, because of van der Waals forces, CH3i higher than CH3br, higher than CH3cl. Put both of these together, and this is the order of boiling points that you get. This is also in NCERT. Don't have to mug this. This is just to get an idea of what the range is. Okay, cool. Now, how does branching affect boiling point? What is boiling? Boiling का concept क्या है? Boiling का concept ये है कि दो मॉलिक्यूल्स के बीच में, दो लिक्विड मॉलिक्यूल्स के बीच में, whatever attractive forces are there, we kind of break them apart. That's pretty much what boiling is, right? You give it enough energy so that it escapes the surface. And technically boiling is when vapor pressure is equal to atmospheric pressure. Vapor pressure. So अगर branching ज्यादा हुई तो this attractive force reduces. इसीलिए branching ज्यादा हुई तो boiling point हो गया कम. Here is the numbers to stats to prove that to you. There is a theory कि branching बढ़ने से you would expect it to be lower, and that's exactly what happens. 346 Kelvin, this is all in Kelvin, and 375 Kelvin is for straight chain compound. The number of carbons is the same, so same formula. All of them have the same exact formula, which means there are 4 carbons and 1 bromine, right? This has bromine as second carbon. This is a tertiary butyl, I want to say, group attached to bromine. All right, cool. Yeah, we good? Okay, and this is what it looks like. Yeah, bromobutane ka boiling point is 375, etc., etc. Cool. So, if you're going to compare hydrocarbon and haloalkane ka boiling points, there, what do you think? Just give me your inputs in the chat. Yeah, the general idea is that haloalkane has greater polarity and higher molar mass. So what do you think the boiling point is going to be? It's kind of obvious, right? Polarity bhi zyada hai, mass bhi zyada hai, and both of these factors help make the boiling point of the haloalkanes to be higher. That's it. It's as simple as that. Okay, so that's one quick theory to get out of the way, and this is mainly because dipole and van der Waals forces. Same things that we've spoken before. If I look at haloarenes, things become interesting. Haloarenes, isomeric ones, and specifically dihalo compounds, में ज़्यादा फर्क नहीं पड़ता है. You're wondering, why did I suddenly bring about dihaloarenes? Such a random thing to bring about. Because we look at melting points, and that has an interesting, contrast to this. यहाँ पे more or less same है. देखो, like 4-5 डिग्री का ही फर्क है, ज़्यादा फर्क नहीं पड़ा है. 453, 446, 448, so like ये this somewhere in the middle, and ये थोड़ा ऊपर 5 डिग्री ऊपर, 2-3 डिग्री नीचे, ठीक है? That is what is happening, right? By the way, this is in Kelvin, so if you subtract minus 273, what is that? Let's do it on this one, because this seems like it has nicer math. If I subtract that, I get what? 80 degrees Celsius, 180 degrees Celsius. So that's pretty high, 180 degrees Celsius. Okay, cool. So that's the boiling point of haloarenes, and they're pretty much the same. It doesn't matter अगर ये 1,4 है or 1,3 है or 1,2 है. You call this ortho, you call this meta, you call this para, right? It doesn't matter. Almost same. Keep this in mind. We'll come back to this when we talk about melting point. Well, which is right now. Melting point, when you increase packing, then melting point is better. What do you mean by packing? ये समझने के लिए ना, the best example that I give is usually that of water itself. पानी का it has beautiful packing in the solid state. Okay. You know how that works, right? Have you studied that? Maybe hydrogen chapter आपके उससे निकाल दिया गया syllabus से, but water has a very, very crystal funky structure in ice, right? That's why it has it's got really good packing. So anyway, to understand this concept of packing, or forget water and ice and all that, take something simple as NaCl. NaCl has a lattice structure, which is why it has a pretty high melting point. Okay, so obviously we're not going to have such good, structures like a metal or a metal salt, but if there's anything that improves quote unquote packing in the solid state, that will cause it to have a higher melting point. And we're going to address that right here. We're going to address these three isomers right over here of what? Dihalobenzenes right here. You'll see that there's a very stark difference. Look at this, 256 Kelvin, 249 Kelvin and 323 Kelvin. इसका देखो काफी ज़्यादा हो गया. If you want to see the difference, it's 50, about 70 degrees Celsius का difference, yeah, or Kelvin, it doesn't matter. The change is the same, right? 70 degrees Celsius, 70 Kelvin, whatever. But this, again, 1,4 is because of para. This is nice packing. Yeah, that's all there is. It's an ordered thing. It's got symmetry, so it has better packing. I've used words. It may seem like मैंने loosely symmetry शब्द use किया है, but symmetry बहुत बड़ी चीज है, right? If you go into materials engineering, if you try and study molecules, symmetry is crazy. It helps you do a lot of things, and it also removes a lot of things that you can test, right? अगर किसी चीज में symmetry है, तब वो optically active नहीं होता है. Those ideas, yeah. Stereoisomerism के point of view से and packing के point of view से symmetry मतलब that's good. It's going to have a high melting point. This has symmetry. These two not so much. Sure, you can say कि इसमें इस type की symmetry है. This has this kind of symmetry. Cool. That's one. This has many. This has multiple planes of. ठीक है. I'm not gonna go into that. Symmetry अगर आप पढ़ना चाहें तो अलग से आप पढ़ सकते हो. I did this in a lot of detail in stereoisomerism in the last year's sessions. Bento links में you can check those out. All right. What is solubility? That's the next topic. What आपको लगता है soluble होगा? मैंने बताया कि थोड़ा बहुत polarity तो होता है. So maybe it will be soluble because water is polar and ये haloalkanes भी polar है. Okay. Do you remember from chemical bonding? By the way, just taking a temperature check. Everyone is good and alive and happy and kicking on the chat, right? Just checking. Just give me a thumbs up if you're all good. You're all cool. अगर कोई doubts है तो पूछ लेना. I'm going to continue because I really like this topic. So I'm going to flow. It's a monologue-like thing. I'm going to just go ahead. So solubility. Okay, ठीक है. मैंने बोला कि polar है, which you agree with. Water भी polar है. That's good. Like dissolves like. अब ये सब बचकानी वाले बातें ना छोड़ दो. Like dissolve like is a thing you studied in 10th grade. बचकानी नहीं है. It's a lower grade thing. 9th, 10th grade. Now we're going to have to go into details, the energetics of things. What are the energetics? देखो, for something to dissolve, solid के लिए हम लोग बोलते थे ना कि एक lattice energy का concept होता है, and then there is hydration energy, right? इन दोनों अगर ये overall negative हुआ, then solvation happens. Otherwise, it doesn't happen. Okay. Hydration अगर पानी हो गया, कोई और solvent हो, solvation होता है. So here, what are the positive and negative energy effects? That is what we have to look at. Okay, here they are. The positive energy effects are these guys, and the negative energy is this. The strange thing is the energy required to break attraction between haloalkane molecules. Oh, so if you've got CH3Cl, already they are quite polar, which means they like themselves. They don't really want to get with water. They already have some sort of hydrogen bonding with them. So I've got to break that. Yeah, I'm saying the word hydrogen bonding a little loosely. Let's just generalize करने के लिए energy input required to break attraction between haloalkane molecules, whatever they may be. They may be hydrogen bonding, maybe van der Waals forces, या कुछ भी हो रहे हैं. हमने देखा ना dipole forces कुछ भी हो सकते हैं. उन सब को लेके generally बोलते हैं इसके लिए energy देनी पड़ेगी. और हाइड्रोजन बॉन्ड्स जो पानी में एग्जिस्ट करते हैं उनको ब्रेक करना पड़ेगा. Do you remember this AA-BB interactions being weaker than AB interactions? Hence, yaar, you remember that? Yeah, from solutions का chapter, sort of, kind of, वही यहाँ पे हो रहा है. And here, positive energy is greater than the not really hydration, solvation नहीं होता है इतनी अच्छी तरीके से, but it is greater than energy released between the new interactions, which are the AB interactions, right? So AA plus BB interactions, जो आपको positive energy देनी पड़ेगी, this is greater than AB interactions, so which is a negative energy release. Hence, solvation नहीं होता है, सॉल्वेशन नहीं होता है. All right, good, blood. All right, cool. That's cool, right? So again, don't mug like dissolves like. थोड़ा सा there's more to the story. Like you see haloalkanes, right? Okay, great. ठीक है. इसीलिए what's the conclusion? Conclusion ये है कि solubility कम होती है पानी में of haloalkanes. But okay, इसमें कम होती है. What about organic solvent? Organic solvent क्या होता है? बहुत ढेर सारे होते हैं ना. Well, in fact, CCl4 is a solvent, CS2 is a solvent, DMSO, B क्यों लिख दिया? D लिखना था. DMSO, dimethyl sulfur oxide. What is DMSO? देखते हैं. We'll talk about all of these, some of these. जो आपके syllabus में not strictly है, but we'll talk about this anyway because it's fun. In this case, this energy is almost the same. Remember, these are both positive energies. This is a negative energy. ठीक है? They're nearly the same, so it's kind of soluble. ठीक है? It is soluble in organic solvents. I've given you an example of some of them. We'll look at more organic solvent. होते क्या है? There are two broad types, right? There is protic, polar, or aprotic, non-polar. Mixture of these four terms. ठीक है? We'll give you four different things. So polar, protic, protic and non-polar, is that a possibility? We'll see. And aprotic, non-polar, or aprotic and polar, we'll see. They are mixture of these terms. Okay, this is what will help you figuring out SN1, SN2 reaction, etc., etc. I'll give you some stuff to read. By the way, there's a site called Master Organic Chemistry, which is wonderful. अगर आप organic chemistry बढ़िया तरीके से समझना चाहते हैं, this is a beautiful site. I'll show it to you. Maybe by the end of the session, I'll show it to you and I'll show you how to navigate it. It's all free. It's completely free. All the resources I tell you here are completely free. All right. Density की बात करते हैं. That's the last physical property tool we're going to talk about right now. देखो, जाहिर है कि अगर मैं alkane में से हाइड्रोजन हटा के एक हाइड्रोजन एटम डाल रहा हूं तो उसका मास बढ़ रहा है. वॉल्यूम नॉट सो मच, बट मास काफी ज्यादा बढ़ रहा है. ओके, सो specifically for bromo, iodo and polychloro derivatives of hydrocarbons, they are heavier, मतलब कि more dense than water. How do I know this? Well, there's a way to figure out density. It's not rocket science. बहुत simple है. ठीक है? And if I increase the number of carbon halogen atoms, then density बढ़ जाती है. And what are we comparing with water, right? Which means they are liquids. तभी तो हम लोग पानी से density compare कर रहे हैं. अगर वो gases होते then we would not compare with water. It doesn't make sense because water would be like 1,000 times that of air, right? Density. So we're not going to talk about that. So this is just like an oil, right? Monochloro is just like an oil, density less than water. These guys, interesting. काफी ज़्यादा. Look at this, 1.8. Almost H2SO4 की density, that is 1.8. It's close to that. Specific gravity बोलते हैं ना? Same चीज. All right, cool. Now if I increase the number of fluorine atoms, this is basically same carbon, different X value, right? Fixing carbon and different X. Okay. Now, what if we increase the number of, say, just chlorine? Increase chlorine, same carbon. Look at that. Clearly, density is increasing. All right, sweet. Okay, quick question. इसमें से सही statement क्या है? Molecules with better packing have lower melting point, or haloalkanes are insoluble in organic solvents. As branching of parent chain increases, boiling point decreases. Yeah, सब सही है भाई. This is a great question because this encapsulates everything we have learned so far. So, before I analyze each option, guys in the chat, please give me inputs as well. Molecules with better packing have lower melting point. नहीं, अगर पैकिंग अच्छी है तो वो सॉलिड स्टेट में पैकिंग अच्छी होगी तो उसको तोड़ना मुश्किल होगा. ठीक है? So this is off. They have higher मेरे हिसाब से. तो ये वाला हो गया गलत. And because of that, this also goes away. Now you have to decide between B and C. Haloalkanes are insoluble. No, they are soluble. We just saw that, yeah. They are insoluble in water. They are insoluble in water. Okay, so ये भी गलत हो गया, which means C must be correct. Let's read C anyway. As branching of parent chain increases, boiling point decreases. Yeah, this is good. We just saw that with some data. देखो, we can talk about a lot of logic, right? About in organic chemistry, inorganic chemistry, physical chemistry. But if you get into real world stuff, especially in organic chemistry, या फिर in organic chemistry, then you have to look at data. At higher levels, data just rules everything else. Okay, cool. So it's good to read the NCERT because आप logic बहुत चीजें याद रखेंगे, which is good. Logic is great. Logic is awesome. But you also have to read a little bit of data and get an idea, feel of things. Acha, theek hai. This is kind of how things work. Another quick question. Yeah, all right, blood, sure. Thanks for that. Conversion of benzene diazonium chloride. अरे ये क्या हो गया? ये तो last session में पढ़ाया था. Diazonium chloride to chlorobenzene is an example of which of these following reactions? अच्छा, ठीक है. Birch reduction ये तो आपने पढ़ा ही नहीं है, तो may not be. Friedel-Crafts, maybe Sandmeyer, maybe Woods, maybe. Benzene diazonium chloride मतलब N2Cl, N2 plus Cl minus, to chlorobenzene. CuCl डालते हैं ना शायद. अच्छा, अभी याद आया. इसको हम लोग बोलते हैं Sandmeyer, right? If you have chlorine, CuCl or CuBr, that is called Sandmeyer. If you do CuI, you get iodide, but it's not called Sandmeyer. You can use not CuA, you can use Ki as well. That's not called Sandmeyer. So मेरे हिसाब से Sandmeyer होना चाहिए, which we have done before. Yes, Pooja, thank you. Absolutely. Good, well done, well done. Simple questions, but hey, this is the kind of thing that come here. Okay, now this is a slightly tricky question. You got aniline, and I'm doing this whole NaNO2, HCl, 0 to 5, CuCl2, CuCl. This is what? ये तो Sandmeyer ही लग रहा है मुझे, right? This looks like, we just looked at Sandmeyer, so this must be it. And then you're adding Br2 and FeBr3. अच्छा, ये क्या है? This is a Lewis acid and also bromine. So it looks like we're going to be splitting bromine into Br plus and Br minus. Right? That's what this guy does. This FeBr3. Okay, great. Oh, so electrophilic substitution reaction of benzene. Interesting. So pehle looks like देखो NaNO2 HCl basically just forms HNO2 in situ, है ना? ये and then it gives you NO plus as the ion, which then becomes N2Cl. वो तो हमने अभी लिखा ही था. This becomes N2 plus Cl minus. Okay. Then you do CuCl. This becomes this. All right, great. बढ़िया. Excellent. Okay. What is next? Now, after this, if I'm adding Br plus, what? This is interesting. Sandmeyer बिल्कुल सही बोला आपने, पूजा. But product क्या बन रहा है? A is this. Do you agree? Please give me a thumbs up if you agree with this. Product A is just chlorobenzene. Product B plus C. B plus C. That's interesting, isn't it? मतलब ये बोल रहे हैं दो प्रोडक्ट बने. दो क्यों बनेंगे? This is because, and I don't know why I raised that. That was right. This is because a negative charge would be there on this, on this, on this. So this is orthopara directing and ring deactivating. मतलब कि इसमें से सिर्फ एक होगा and not all. Usually, if you have something like an OH, it is orthopara directing and it is ring activating. तो अगर मैं एक क्लोरीन डालूं तो भाई सब में लग जाएगा. But that's not going to happen. So you're going to get two products. What are the two products? You're going to get this. And you're going to get this. Out of these, one of them is going to be major. The other one's going to be a minor product. And these are your B plus C. I'm going to use a different color so that this doesn't get lost out. B and C, and this is A right here. Cool? Yeah, they have an inductive and resonance effect. They run counter to each other, right? है ना? Inductive is stronger, so electron withdrawing. इसलिए net effect is कि halogens are deactivating and orthopara directing. Yeah, this stuff from 11th grade. Yeah, nothing too complicated. आगे बढ़ा जाए? Yeah. All right, sweet. Let's move on. Let's just move on. Couple of more questions. Let's do one more question. Do we have time? We have a lot of time. Okay, how about this one? This is a nice question. Yeah, मजेदार सवाल है. Let's look at this. The products of the following reaction. I know ये last session का content है, questions है, but you've got to be prepared with whatever we have done before the current class. Okay, so please be mentally prepared for all of this. So now I've got an interesting thing. I've got an isopropyl group attached to benzene. उसके साथ में react कर रहा हूँ bromine and FeBr3. So again, I've got a Br plus group, and this is going to be an electrophilic substitution reaction. Especially SNAR बोलते हैं substitution, right? Whatever, it's okay, doesn't matter. But Br plus is the electrophile. So where does this go? This is going to bring activating or deactivating. Well, it's a R group, so I think it should activate thing, and maybe ortho and para, right? Ortho and para is where things would go. What do you think the answer to this is? Take some time to figure this one out. आपको क्या लगता है? Blood and Pooja, what do you guys think? Anybody else? Wajid, are you here? Mehak, what do you think about this? What is this form? थोड़ा सोचो, जरूरी है. What do you think about this one? Either the main idea is steric hindrance. See, in organic reactions, you have a lot of factors. This, that, falana, बहुत चीजें हैं. But the one factor that supersedes everything is steric hindrance. अगर किसी चीज में steric hindrance हो रहा है, then that product will not get formed. And both of these are not good from that point of view. Which is why you will get just one product. सिर्फ एक product मिलेगा, which is going to be the para product. Okay? Yeah, exactly. That's it. Okay. Now, अभी तक हमने जो पढ़ा है in today's class, उसके बेसिस पे इसका आंसर बताइए प्लीज. I want you to put either a greater than sign or a less than sign in all of these. The easy thing is they all follow the same order. मैंने कुछ mix up नहीं किया to make your life hard. So, that is the boiling point of bromoform greater than of dibromomethane, bromomethane and chloromethane. अब ये bromoform क्या बला है? This is CHBr3, just like chloroform. What is chloroform? Chloroform is CHCl3. ठीक है? Dibromomethane is CH2Br2, obviously. This is CHBr, 3H3Br, and this is just what? Cl. Oh, interesting. CH3Cl. Interesting. Okay. Cool. So, इसमें से सबसे ज्यादा किसका होगा boiling point? Not melting point, we're talking about boiling point. What do you think? So, would you put a greater than sign or less than sign in between these? देखो, this is fairly direct because you've got chloro, you've got bromo. Mass बढ़ रहा है, तो boiling point बढ़ेगा. And और bromo बढ़ रहे हैं, दो हो गए, एक के बजाय दो bromo हो गए, यहाँ तीन bromo हो गए, ये भी बढ़ेगा. Simple सा है. You don't have to think what's that all, right? Because mass increases, so we go with this way. Yeah. Oh, sorry. In this direction. In this direction, the boiling points are increasing. All right. Next one. Arrange these compounds in an increasing order of their boiling points. Same idea. Either this or this. Okay. What do you think we're going to do? Well, isopropyl chloride. ये क्या बोला है? Isopropyl chloride. Okay. 1 chloropropane. अच्छा. 1 chloropropane. 1 chlorobutane. 1, 2, 3, 4. अच्छा. ठीक है. So, there is branching here right away, which means this should have the lowest one, right? Branching, and this has 3 carbon, and this also has 3 carbon. So, in this case, maybe I feel it should just be this, right? Same. Yes, Pooja, absolutely. Simple one, simple one. Mass is one factor in this, making this one the highest, and here branching makes this the least. All right, sweet. Badhiya, badhiya, badhiya. Good, you guys are great at this. All right, let's look at some chemical properties right now. Specifically, we're going to look at substitution reactions. There are multiple ones, but we're going to focus on what happened to this. Acha, okay, yeah. I was wondering itni dheere kyun aa raha hai. All right, substitution, elimination are the ones we're going to look at. Today, aaj ka focus is going to be on substitution. Substitution kis cheez ka? We're going to remove the halogen. Yeah, easy thing to do. Kaise karenge? We'll look at the different sort of ideas we can do here. This is called nucleophilic substitution specifically. As I said, maybe this is an electrophile, and there's something else called a nucleophile. Now, this can be represented as Nu minus or Nu with a couple of electrons, which means that this is where things get interesting. This is what is awesome about organic chemistry. You needn't always have a negative charge. You can just have excess electrons to make this work. I'll show you how that works. Yeah, you remember the concept of Lewis acids and Lewis bases? So we are talking about a Lewis base here that has an excess of electrons. Okay, that is what is called a nucleophile. Sure, it can also have a negative charge. Substitution reaction, etc., etc. Definition, just move on. If you do it with the nucleophile, it's called nucleophilic substitution reaction. Okay, cool, great. This is how reaction actually looks like. You've got R with a leaving group. In this case, my leaving group is X. X leaves, uske bajaye Nu minus or Nu with a couple of electrons comes into the picture and forms this, giving you the leaving group. Leaving group matlab could be X minus in this case. Okay, this is a general reaction for a substitution reaction. Now, what on earth is a nucleophile? And again, these usually take place at the sp3 carbon. अब ये sp3 carbon क्या है? This is an sp3 carbon, and yeah, sure, you can have primary, you can have secondary, or you can have tertiary carbons as well. But they're all sp3 carbons. All of these sp3 carbons. ये मैंने पहले सेशन में आपको बताया था कि sp3 carbon क्या होता है, सब allyl है, ये सब चीजें हैं, ठीक है, cool. Please revise that if you feel this sp3 carbon is a challenge. We've done that in bonding, we've done that in 11th grade generally as well. अब nucleophile क्या बला होती है? This is my favorite part of this session. Okay, all right. It has at least one pair of electrons that are not bonded. That is what a nucleophile is. Okay, so one unshared, मतलब कि let's put it this way. So the orbital could be hybridized, usually is, but it has a lone pair of electrons. Okay, that is what a nucleophile is. And it's always a Lewis base, so it can be neutral or it can be negatively charged. What do I mean? Like say ammonia, right? It has 3 bonds with carbon, 3 bonds with hydrogen, and this. Or very interestingly, ROH, ठीक है? 1, 2, 3, 4. अब we do something like add a base to this. We can. Okay, what happens? Well, the base does something fascinating. This goes and breaks this bond heterolytically. Okay, ये क्या कर रहे हैं? इस तरफ. Okay, 1, 2, 3, 4, 5, 6. This gets a negative charge, Na plus, and then we get water. Yeah, so in presence of a base, this behaves like an acid. And this is where things are wonderful in organic chemistry, right? It ties in the ideas from ionic equilibrium. मतलब कि एक acid और base relative idea है. There is no absolute concept of ये तो acid है, ये तो base है. Something that is acidic can behave like a base with a stronger acid, है ना? That is what we are saying. So alcohol acid है, base है. Well, you can say according to pH it is something. But if I make it react with a really strong base like NaOH, Na plus मतलब OH minus भी होगा भाई साथ में इसके साथ, ठीक है? If I make it react with a very strong base, it will behave like an acid. If I make it react with a very strong acid, it will behave like a base. क्या करेगा बेचारा, है ना? खैर, so I make it react with this and it forms this sort of a thing. And now this, both of these species, I'm going to mark them with a different color, are nucleophiles. This is a nucleophile. This is a nucleophile. Yeah, the green stuff is a nucleophile. This is where things become interesting. And you're like, hold on, एक second. फिर फर्क क्या हुआ between a nucleophile and a base? Because इसमें भी negative charge है, तो ये भी nucleophile हो सकता है. You'd be right in thinking that. This can also be nucleophile. You are absolutely right. So what is the difference between nucleophile and a base? We'll talk about that. यहाँ पे देखो एग्जांपल्स नीचे बहुत दिए हुए हैं. वही चीज मैंने आपको ड्रॉ करके दिखाया. यहाँ पे दिया हुआ है Cn minus, OH minus, Br minus, I minus, NH3H2O. H2O, हाँ H2O भी हो सकता है न्यूक्लियोफाइल. क्यों? क्योंकि इसके पास भी हैं 4 4 इलेक्ट्रॉन्स, 2 लोन पेयर्स. या ऑलराइट Adil, wow, that's great to hear from you. How you doing in life, man? Haven't heard from you in a long time. But you guys think that I think they've all gone off colleges, so that's great. So कभी कभी न्यूक्लियोफाइल्स एक अजीब तरीके हो सकते हैं. मतलब कि 2 अलग अलग एटम्स पे भी इलेक्ट्रॉन्स हो सकते हैं उनके that are not reacting, they haven't reacted anything else, they are lone pairs. So they have 2 different forms. यहाँ पे भी reaction can happen in both places. What do I mean? Say something like Cn minus, right? Sometimes this guy will go ahead and give its electrons. Sometimes this will go ahead and give its electrons. In that case, you will get this sort of a bond or this sort of a bond. This is called an isocyanide and this is called a cyanide. And you will learn about this when we do nitrogen containing compound. We'll talk about this in detail. Okay? These are called ambident nucleophiles. So what is nucleophilicity? What's a nucleophile? It's the tendency to give away that unreacted electron pair. Okay? That is a nucleophile. Now, what is a good nucleophile? Good nucleophile क्या होता है? अच्छा nucleophile क्या होता है? अच्छा nucleophile मतलब जल्दी से reaction करेगा? Perhaps. That is one idea. Now, you notice कि अभी मैं बार-बार बात time की कर रहा हूँ. Quickly, I'm saying जल्दी. There's a reason behind this. There's a reason behind talking about time. We'll keep this in mind, okay? That I mentioned कि जल्दी होगा. if something increases the electron density, because what is a nucleophile? Something has an electron that it wants to give away. If something increases the electron density, then it is a good nucleophile. It increases nucleophilicity, हम लोग अंग्रेजी में बोलते हैं. ये सब शब्द हैं, आपको थोड़ा बहुत समझना पड़ेगा कि nucleophilicity means good nucleophile. Okay. You see what this means? इसका क्या मतलब है? Q, why, what, how, where? See, this is an activating group. And this is a deactivating group. Right? So this is decreasing electron density. This is increasing electron density. इसीलिए this right here, this is a minus charge here, minus plus. This is what actually happens. ना देखो अगर इसको पानी में डालोगे तो ये चार्ज सेपरेट हो जाएंगे. Na plus is going to chill. This whole thing with the minus sign is going to chill again. So this is why this is a better nucleophile. 1 is a better nucleophile than 2. Are we good there? Any doubts on this point? This is important. Okay. This is what will lead to understanding SN2 reaction होता क्या है. Please tell me if you guys have any doubts on this one. Next slide, and this is fascinating, right? If I increase the size of the atom, कौन सा atom? कोई भी atom जिसपे negative charge है या फिर electron है, right? Which atom? Donor atom. Donor atom मतलब जिसके पास electron है देने के लिए. अगर वो बढ़ा देंगे तब वो polarizable आसानी से हो जाएगा. What do I mean? See a small one, small atom versus a big atom. If it decides to just have its couple of electrons on this side, it's easier as compared to this. I don't know if you remember this from bonding, but these are things you have covered. Yeah, there van der Waals forces, etc. जो भी चीजें होती हैं. Polarizability, and also we did something called Fajan's rules, right? Big this thing. Big negatively charged atom is good because it's easily polarizable. So अगर ज़्यादा polarizable है, then it's a better nucleophile, which means clearly that something like iodine will be a great nucleophile क्योंकि बहुत बड़ा है. Exactly, that's what we're going to talk about as well. Before we talk about that, अगर मैं एक पीरियड में जाऊं लेफ्ट टू राइट, मतलब देखो इसका एटॉमिक नंबर है 6, फिर 7, फिर 8, फिर 9, राइट? न्यूक्लियोफिलिसिटी कम होती जाती है. Why is that? Why is that? Because look at this. This is really small, decently large. Okay, now let's stop talking about small, large, and all of that. Let's look at numbers. That is what we will do. So if we take CH4, that's a very weak acid and a base. It's like whatever. It's neither. What are we talking about? It's neither. This, which is why this becomes a very strong base. Okay. Similarly, water is like, it's okay, neither an acid nor a base. But OH minus is a very strong base. You see where I'm going with this? We're talking about the Bronsted. Theory of acids and bases. Conjugate acid base pair. अगर एक चीज वीक एसिड है तो उसका बेस बहुत स्ट्रांग होगा. जितना वीक एसिड उतना स्ट्रांग उसका बेस. So water is definitely a weak base, but this is like a very strong acid. Water is definitely a weak acid. That's a very strong base. Similarly, ammonia also is not a good acid. It's a decent base, not a good acid at all. Which is why NH2 minus is a good base. Like, hold on. Why are you talking about basicity? We're supposed to talk about nucleophilicity. Here's the deal, right? Well, every base is a nucleophile, but every nucleophile need not be a base. We'll talk about that as well. Let's talk about something easier पहले दो उसके before. The easier thing is, in a polar protic solvent, nucleophilicity इस order में होती है. मतलब कि I minus, because it's large, polarizable, will have it's going to be a better nucleophile as compared to this. Okay. Polar protic solvent. Yeah. HCl is a polar protic solvent. Water is a polar protic solvent. HCl is not a good solvent, obviously, because it's also an acid and reacts with stuff. But water, sure. Okay, cool. CH3Cl. All of these are polar protic solvents. All right, cool. ठीक है. The next idea, and this is something I've already told you, the reason behind it, yeah, कि RO minus is going to be a really good nucleophile and a really strong base as well. क्यों? क्योंकि the alcohol is not that great an acid. So its conjugate base is going to be pretty strong. Interestingly, this idea is probably something you may not have heard of before. But मैंने आपको already बोल दिया था, कोई भी चीज that's bulky is not good. Now, what is a nucleophile doing? Remember, the original thing क्या था? This के साथ you've got nucleophile that then gives you RNU plus Lg. मतलब nucleophile is attacking this, right? Attack. तो अगर जल्दी कर लेगा, quickly, then it's good. If it is really bulky, it's not going to happen. It's like, dude, there's no space, right? There is steric hindrance over here, जिसकी वजह से this is not a good nucleophile, and this one right here, pretty good because it can approach the electrophile. What is electrophile? Look, if something is a nucleophile, it wants a nucleus. That means the nucleus should want electrons. So nucleus is basically the electrophile. Something like this is a carbon atom, right? We're talking about the carbon atom, which is electrophile. Electrophile. But does it have a slightly positive charge? Sure. Because remember, Rx, this is negative, this is positive. So yeah, sure, electrophile. Okay, cool. Don't get thrown away by all of these terminologies. Okay, so this idea, last idea we talked about, then we'll go into SN2 very quickly. How do you relate this nucleophilicity and basicity का idea? Yeah, मैंने बताया कि all bases are nucleophiles, but all nucleophiles are not bases. What do I mean by that? Nucleophilicity is how readily a species is able to attack an electron deficient atom. मतलब कि जिस चीज को इलेक्ट्रॉन की जरूरत है उसको कितनी जल्दी कितने efficiently अटैक कर सकता है, ठीक है? Because it has a lone pair of electrons. Okay. What is basicity? Basicity is to specifically remove an H plus. That is what is a base, defined by Laurie Bronsted and all that. ठीक है? ये फर्क है इन दोनों में. Okay. Here's a quick question. Blood, Pooja and Adil, आप भी ट्राई कर लो. सबसे रिएक्टिव न्यूक्लियोफाइल इनमें से कौन सा होगा? I've already given you the answer multiple times on this one, but try it out. सबसे reactive nucleophile. Let me mark out the ones that are ridiculous. Steric hindrance. So ये तो नहीं होगा. ये भी नहीं होगा. Bulky है. It's got a couple of carbons around. Steric hindrance. Between A and B, what do you think the answer should be? I have narrowed it down quite a bit. You know, KBC में बोलते थे ना कि कुछ दो options को eliminate कर दो. I forgot what it was called. I did that for you. Phone a friend, audience poll. I don't remember that one. Just maybe we'll just eliminate two options. Something that's reactive shouldn't be very stable. This is pretty stable. What do you mean pretty stable? Look, if you guys remember this is a decent, it's an acid. It's got a pKa, it's got a pH of 10. If it's got a pH of 10, that means it's okay, not a good acid, but it's okay. pH, pKa of 10, not pH. pKa of 10, okay, great. Matlab, if I remove this, it's going to be a pretty stable base. Okay, matlab it's not good, doesn't want to react either. So C6H5O minus is like stable. Why is it stable? Because, hold on, this then happily become this. This comes here, etc., 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 etc. So yeah, it's good. It's happy. It doesn't want to react anymore. It's happy, which is why this is not going to be the answer as well. The most reactive nucleophile is going to be this. This happily wants to give away the electrons. It's like, ठीक है, I'm good. You can take away the electrons, do whatever you want with them. This one not so much because this is stable and these two are sterically hindered. Okay. Whew. All right. Now let's talk about the leaving group. हमने nucleophile को काफी डिटेल में पढ़ा है. अब leaving group का पढ़ते हैं. Leaving group मतलब something that should leave easily. If it's big, it's great. It can break away that bond easily. Look, I've got a RX bond. इसकी polarity जितनी कम होगी उतना अच्छा होगा. Polarity अगर कम है, then it's going to be a good leaving group. Yeah, if polarity is high, then it's like, dude, it's got to be sticky. It's not going to go anywhere. Yeah, it takes away the electron pair. Okay, so a weak base is a good leaving group. Huh? Weak base is a good leaving group. इसका क्या मतलब है? Let's go back and read that. In a reaction where substrate molecule becomes cleaved, ठीक है, मतलब टूट जाता है. मतलब this is just saying कि Rx would take electrons and go this way. So it would form R plus plus X minus. That's what it's saying. Okay. So, acha, because it is forming this, and if this is stable, then that is great. If this is stable, that means it is weak. It doesn't, not reactive. Not reactive, matlab weak. इसीलिए हमने यहाँ पे लिखा है weaker bases are good leaving groups. Because at the end, if this is being formed, it doesn't want to react anymore. Not OH minus. OH minus is a really strong base. Don't form that. So, if you compare all of these, yeah, good leaving groups, iodine at the top because large size and polarity is not that great. Polarity also is lower. you'll see that here it's saying OH is a good leaving group. Well, as compared to these guys, look at these. These are not. These are very strong bases. Yeah, this is strong base. And this is weak. This is pretty weak. Even much stronger than OH minus. These are strong base. Again, this is a very strong base, RO minus, and not so much. This is a weak base. How do I know this? Well, the acid also is pretty weak. You remember RCOH is pKa value was around 5, right? 10 power 5 was the dissociation constant of 10 power minus 5 dissociation constant of acetic acid. I'm just going with that. Okay, so pKb would be 14 minus this one, 9. That's pretty weak. It's not good. This is a weak base. So anything that forms a weak base, great leaving group. Whew. Now that we've done so much of theory, so much of theory, we can finally, we can get to nucleophilic substitution reaction. Hold on. The name of this session had physical properties and nucleophilic substitution reaction. And what do we do all this time? Look, everything we've set up till now will help us understand this better. And we're going to quickly do SN2 reactions. These are easy to understand. SN1s are also easy to understand. But what do these numbers mean? SN2 का और 1 का मतलब क्या है? 2 is talking about, 1 is talking about kinetics. मतलब order of the reaction की हम लोग बात कर रहे हैं. तो इसका order हो गया 2, इसका order हो गया 1. And because of that, because you already know kinetics, I'm going to throw another thing in here. This is a bimolecular reaction. Bimolecular reaction. मतलब कि दो मॉलिक्यूल्स दोनों मैटर करते हैं. कौन से दो मॉलिक्यूल्स? एक न्यूक्लियोफाइल, दूसरा सबस्ट्रेट. ओके, दोनों की कॉन्सेंट्रेशन मैटर करती है टू गेट द किनेटिक्स का आइडिया. सो रेट इज गोइंग टू बी प्रोपोर्शनल टू न्यूक्लियोफाइल का कॉन्सेंट्रेशन एंड द कॉन्सेंट्रेशन ऑफ द सबस्ट्रेट, व्हिच मींस दिस कुड बी थॉट ऑफ एज एन एलिमेंट्री रिएक्शन, राइट? बिकॉज I've got two substances और दोनों का रेशियो स्टोइकियोमेट्रिक कोएफिशिएंट is this rate itself. Cool, great, awesome. This is the final reaction, etc. that happens. What is the mechanism of the reaction? This is where things become interesting. इसलिए chirality की बात हो रही थी, बहुत चीजों की बात हो रही थी. Now, this is a one-step reaction, elementary thing, as I told you, but this is a little bit complicated. I'm not going to say complex because complex means something else in kinetic, but it's complicated. You get a weird transition state where all the bonds are formed. Like this carbon supposed to have 4 bonds, here carbon has 5 bonds, which is weird, but it's sp2 hybridized. Okay, I know this is a little bit over the top, the things I'm telling you, the information I'm giving you. You can read up more about this, but it's beyond the scope of our discussion as to why it's sp2 and all of that. But this is a transition state. Matlab, these bonds are not entirely there, not entirely broken, they're just kind of hanging around. ठीक है? So these things matter now. Okay, what is this? This is a wedge, and this is a dash, which means that this is forward and this is backward, and this is the plane. This is the plane of the molecule. So CH and Cl are in one plane. H उसके सामने है और दूसरा H उसके पीछे है. You know there's a tetrahedral being formed, right? So I'm just saying C यहाँ पे है, एक H इधर और एक पीछे H और अच्छा Cl भी यहाँ पे है. Sorry. Okay, let's do that one more time. C से Cl H और एक H पीछे है और एक H सामने है. ठीक है? That's how we have drawn this. Okay, great. Now with all of that, what do we see over here? Now there is an inversion of symmetry happening. You're like, oh my god, ये क्या चीज है? देखो, if you see this, जो क्लोरीन था जिसके साथ बॉन्ड था एंड OH के साथ जो बॉन्ड बन रहा है, they happen on the opposite sides of the carbon, and you say that it's a backside attack, like पीछे से अटैक करता है, because there's no other place, right? Think about it. If there's a plane of the molecule, right? एक तरफ में क्लोरीन लगा हुआ है, the only place OH minus can come from is the other side. In this case, OH minus इस तरफ से आ रहा है और क्लोरीन यहाँ पे ऑलरेडी लगा हुआ है. So जब OH निकल जाता है इस तरफ से, तो Cl यहाँ से आता है, and hence, did I say that right? Sorry. जब OH आ जाता है और Cl निकल जाता है, तो now the compound looks different from the point of view of stereochemistry. ठीक है? इसीलिए अगर ये chiral carbon है, there is an inversion of symmetry. इसका मतलब I'll talk about that very quickly. So the bonds are partially formed, and the bond between carbon and the leaving group is partially broken. ठीक है? And the main thing is the sp2 hybridization of carbon that still exists. It can be isolated. There's a pentavalent transition state. Yeah, and as I was saying, approaches from the back side. मतलब क्योंकि bonds are already there, right? With chlorine bond already बना हुआ है, the only place you can approach it from the back. ठीक है? Hence, there is an inversion of configuration. Well, if there is a chiral carbon, it may not be there, but अगर chiral carbon है तो inversion होता है. इस पे काफी सवाल पूछे जाते हैं, always and always and always and forever. ठीक है? So this is something you please try and understand. If you don't understand something, please ask me. This one is important. Okay, great. So just showcasing that again, you can look at it from the point of view of this small, easy animation. You got a nucleophile, and this is the middle state, and there you go. There's a transition state. This is the sp2 transition state I was talking about, right? This is planar, and then the bond breaks, and then again you've got something on the other side, right? This is the inverted product right over here. Now this is SN2. How do you remember? कितने steps में होता है, क्या होता है? देखो. As somebody who's running reactions, I don't care कितने steps होते हैं. I mean, sure, अंदर reaction के steps 1, step 2 हो रहे हैं, but मुझे दिख क्या रहा है? What I can experiment, what I can actually see is this number 2. This I know exists experimentally. इसलिए मेरे लिए ये जरूरी है. तो ये experimental idea, which is the order of the reaction, that is what we want to focus on. And hence, this number 2 talks about kinetics. That's how I remember it. And since it's a this has got, you know, not two step, this is a one step reaction क्योंकि bimolecular है, ठीक है? Transition state बढ़ता है, so I remember it. Okay, great. Concentration of what? Alkyl halide and the nucleophile, दोनों पे depend करता है, ठीक है? Now what are the factors that could affect the rate of this reaction? There are multiple of them. We'll look at them very quickly. Nature of alkyl halide, okay? Nature of nucleophile, nature of solvent, leaving group ability. Let's just say this has to be a good leaving group, obviously, right? Okay. Nature of alkyl halide. Okay. I think if I've got a primary one, that's going to be good. If I've got secondary, tertiary, it's going to be bad. Because if the substrate is big, how will the nucleophile attack? Everything is about speed of nucleophile. The nucleophile jaldi se attack kar deta hai, then this reaction happens. Again, that means nucleophile must be small. Nature of solvent, we'll see. This one is interesting. We'll talk about this one a little bit. So nature of alkyl halide, as I told you, कि primary greater than secondary greater than tertiary, because अगर बड़ा substrate है, then it's gonna, nucleophile is gonna have a hard time finding the spot where it needs to get to. Okay, that's the general idea. So large and bulky groups, they hinder the formation of transition state. Crowding की वजह से energy ज़्यादा बढ़ जाती है, and that slows down the rate of the reaction. Okay, cool. This is a simple idea, right? Look at this. Primary में इतना complicated हो गया, secondary gets so complicated, and tertiary is just madness. It's just complete madness. I kept telling you we're talking about speed. Look at the relative rate. Okay, methyl is 30 times faster than first primary, and tertiary primary does not even happen. I mean, the tertiary होता ही नहीं है. It's that slow. Okay, and secondary is very very slow. नेचर ऑफ न्यूक्लियोफाइल, I told you, अगर छोटा सा न्यूक्लियोफाइल है बहुत अच्छी बात है, अगर न्यूक्लियोफिलिसिटी हाई है बहुत अच्छी बात है, ठीक है? तो कॉन्सेंट्रेशन के साथ बढ़ता है. न्यूक्लियोफिलिसिटी क्या होती है? एबिलिटी टू गिव अवे इलेक्ट्रॉन्स इजीली, राइट? सो एनायोनिक न्यूक्लियोफाइल्स मोस्टली गिव SN2 रिएक्शन. एनायोनिक मतलब कि नेगेटिव चार्ज जिस पे हो, दैट इज ऑसम, ठीक है? Nature of solvent, and this is where things become fascinating. The problem with using something like water as a solvent here is that what water will do. See, nucleophile has electrons, and water like, yeah, ठीक है, I can take them. I have hydrogen. I can take them. I can. So what this does is, if a lot of water molecules surround this nucleophile, that's bad. I don't want that, right? I want that charge, those electrons to be available for the reaction to happen. इसलिए water is a bad solvent. What's a good solvent? You remember मैंने आपको बताया था कि polar, protic, apolar, aprotic, ये चार चीजें. So a polar aprotic solvent is the best. So polarity is good, but H नहीं होना चाहिए, क्योंकि अगर हाइड्रोजन आ गया ना तो वो न्यूक्लियोफाइल के इलेक्ट्रॉन्स को ले जाएगा. ठीक है, cool. And usually these are pretty large, right? Polar aprotic, they have a positive center. They don't solvate the ion appreciably. इसका यही मतलब है कि ये जो मैंने सराउंड किया ना, this is not good. This surrounding of the nucleophile by the solvent molecule, this is not good. Which is good because I want a nucleophile to shoot right to the substrate and react with it. Okay. So rate of SN2 reactions increases in a polar aprotic solvent. अब ये क्या बला है polar aprotic solvent? Here is an example. Yeah. Dimethyl sulfur oxide, DMSO. Okay. You can see that. Look, guys, this is a nucleophile. This is the positive negative charge. These are such big molecules. They're like, okay, we'll kind of hang around, like predate you a little bit, but not so much. So you can just do your thing. So apolar, aprotic solvents. The problem is H from the hydrogen. There is from water. Here the hydrogens are like connected to carbons. They're like, all right, we are sharing. Sharing is caring. When the hydrogen is connected to the oxygen with water, There, oxygen wants the electron. So that hydrogen is kind of active. Here, not so much. Not so much. Okay. All right. So there is a bit of a repulsion between these two themselves. Okay. So this is almost unsolvated, which is good because it can quickly go and attack substrate, because that's what we want. Leaving group ability, I've told you this is easy. Yeah. अगर जो है बड़ा है leaving group तो आसानी से निकल जाएगा, right? That's it. So this is a summary of all things SN2 reactions. Yeah. Yeah, and we pretty much covered it very quickly because we did everything before that in so much detail. Nucleophile क्या होता है, leaving group क्या होता है, and what is the rate of reaction and all of that. So bimolecular, okay, this too has talking about that. Bimolecular rate depends on basically nucleophile का concentration as well as substrate का concentration. Okay, reactivity क्या है? Primary की सबसे ज़्यादा. In fact, primary ज़्यादा methyl. Methyl is 30 times, this is 1 times, this is 0.0 times, this is like almost 0, right? Okay, strong nucleophile is good with a negative charge, preferably. I'm not saying strong base, huh? I'm saying strong nucleophile, दोनों में फर्क है. One step है. Okay, you've got transition state, sp2 carbon and all of that. Polar aprotic solvent like DMSO. This is extra information, boss. This may or may not be an NCRT, don't take responsibility for that. But this is important. You need to know what solvent, okay? And there's inversion of configuration, ठीक है? Because अगर sp2 है तो एक तरफ already लगा हुआ है एक चीज, दूसरी तरफ से आ सकता है because it's a transition state. Whew. Yeah, that was it. I see the chat was a little bit chill today. Not too much participation. I understand because these were theory sessions of few questions, and organic is like that. You need to know theory properly to be able to solve questions, right? Physical chemistry ऐसा नहीं है कि मैं आपको एक formula दे दूं, then we'll do 100 questions on it. That's not something we can do in organic. We gotta do a lot of theory. So anyway, I hope you enjoyed this. Share this with your friends if you liked it, and yeah, लोग मिलते रहेंगे to continue this. If you want to check out my stereochemistry sessions, go to the bento link that's in the description and also tagged over here, and you'll be able to check it out as well. Thank you for your time. मैं 8:30 बजे फिर से आऊँगा यहाँ पे on the JEE channel, and I'm going to be continuing chemical bonding. If you have any friends who are in the 11th grade or want to check it out, you can check that out on the bento links as well. It's all going to be added there in the playlist. All right, thank you. Have an awesome weekend. मिलते रहेंगे. Bye bye. Tata. See you. Have a good one.